Okay, so this is the simple VRF system you built yesterday. If we look at the thermal zones, we'll see that each one has a VRF terminal. This is the model you made yesterday. And if we look at the loads at the loop tab, maybe. Why is it doing that? I don't know why it decided to open another file. I'll get rid of it. My computer, strange. So VRF, we open a VRF system here, and we see that there's 10 terminals and 10 thermal zones on our VRF system. That's the system you ran yesterday. So let's make sure we have the right weather. We always check that. So make sure that you get your Hanoi weather, and then you can run this one. So I'm just reopening mine because I've already run it. And if mine takes forever to run. Look at your results and see if you get the same answer. Hopefully we do. Good. Okay. So this is the VRF system, and we know from experience that this system should use less energy than the DX system. But the model says it uses more energy. And this points out that sometimes when you just take things out of as they're given to you, you might not get the correct answer. You have to work to modify the input. And remember, we have 3 places to use energy, and the way the model runs the compressors for VRF makes them use more energy. But we can modify that, and we'll show you how to do that next month. So if we look at the Energy Plus results, we'll see that, as I showed you a minute ago, that even though this is not does not have the outside air system to it, with it already as part of the system from OpenStudio has the same air change per hour as the DX system with an outside air unit. Yes, see the same, this is the same 0.4. Now we normally like we like one air change per hour for a normal office. So this is not enough to make us happy. So now we're going to save this file and open the last file we'll use today, which is the VRF with outside air. It's VRF outside air two story. So let's make sure we have the right weather. Hanoi weather. And then let's look at our loop again. Slow. So you can start this one running while I talk about the loop, if you want to. So just go ahead and go down here and hit the run button. And while it runs for everybody, I'll talk a minute about our loop. I want them to go ahead and run while I'll talk about the loop. So this is exactly the same system we used with the DX. This is a package rooftop heat pump with a heat exchanger, 2 coils, a heater, and a controller, 10 zones, thermostat, and diffuser. But inside each zone, instead of the VRF system, we have instead of a heat pump, we have a VRF now. So let's see how this changes the results. Everyone getting the same results? So now you have 2 different systems and then 2 different systems with outside air added to them. You'll see if we look at the results from Energy Plus, table of contents, outdoor air summary, that now we're getting about an air change an hour. A little short, but almost. So we're all caught up. We have 4 systems. I'm just going to show you so you'll know what's coming next month. If we go to our VRF terminals and hit edit and hit edit up at the top. It's going to come. It's my machine just slow. So this is we're not going to use it today, but the detail that we can come into to work on the VRF terminal and to make changes in how it operates. We have many different things we can do. So, and that's, for making our system perfect, we will be able to show you some changes we can make to that. So now in your files, you have a baseline building, a 2-story baseline. You have a 2-story best practices from yesterday, both of those. Now we've added 4 different HVAC systems that you can use and modify in your OpenStudio. And hopefully you remember that what we try to do with our HVAC system is to cool the space and to remove moisture. And as you do your designs as architects, you need to think about that moisture. The moisture to you will always be able to cool the space for you.
Ngày hôm qua thì chúng ta đã có những cái đường cơ sở, cái giải pháp cơ sở, và sau đấy chúng ta đã có cái tiến hành làm nó thành tốt hơn. Và hôm nay thì tôi trình bày 4 cái cấu hình hệ thống HVAC khác nhau. Đối với kỹ sư thì họ quan tâm đến việc điều hòa, họ quan tâm đến việc là hệ thống phòng tủ lạnh và cái độ ẩm là tự đảm bảo. Và tôi cũng rất mong kiến trúc sư thì quan tâm đến cái vấn đề độ ẩm ở trong phòng.
But the way we remove the humidity, the way we reduce the moisture is the most important thing in Vietnam, and it depends on your designs.
Và cái việc quan trọng nhất đối với khí hậu Việt Nam là cái cách chúng ta khử và
If you want to use natural ventilation and not air condition the building, then we will help you design a building that draws air through the windows and out. The hot air will rise out of the building, and we will help you do that. Bring air through the natural ventilation. But if you want to do that, it is bad habit to decide when it gets too hot to shut the windows and then start the air conditioning. Because what happens is all the moisture in the room then comes out as water someplace. That is why in many places you will find there's mold growing under the paint, or down at the bottom of the wall, the paint slips off because the moisture is built up in the wall.
Và chúng ta sẽ thấy có những cái xuất hiện cái nấm mốc ở trên tường và hoặc là bên dưới cái vách.
So we have to design. It's hard to switch back and forth once you start adding air conditioning. The design of your building is different than for natural ventilation.
Và khi chúng ta sử dụng hệ thống điều hòa, chúng ta phải thiết kế cái hệ thống khác đi.
Now, I am old enough that when I was young, we did not have air conditioning in the United States, except in some big buildings. And it was okay. I'm fine. But once I started living with air conditioning, it's not okay anymore. It's hard for me to adjust to a space that's not air conditioned in the hot weather. And during your career, there'll be fewer and fewer spaces that aren't air conditioned. There will be less and less. Now the bad news, that's why Joe and I come here, is because you will use more and more energy in your buildings and you will have bigger and bigger impacts on the environment because of that. So that's why it is very important for you, as ever you see how many buildings are being built, that you know how to build a building that is air conditioned and comfortable, but does not use so much energy. And very beautiful, but without too much glass. Thank you very much. We're going to have an awards ceremony as soon. Have we heard from them? So I could stand up here and talk a few more minutes. You want me to talk about general stuff? Okay. Would you like to modify? So let's save the system we just ran, and then save as anything you want to save it as. So let's change the name to VRF outside air meeting, because we're doing it today in the meeting. You can change it to anything you want. We'll come over here to our loop. We'll wait for the slow engineer's machine. It's got jet lag from the airplane. And we'll look at the packaged heat pump, and we will say that we don't need a heater So this X at the bottom, we'll take it off. Then we'll say, I don't really want a heat pump. I just want to cool the air. So we'll take both of those off by hitting the X's. Then we will say what I really want is a 2-speed cooling coil. We'll take it and we'll drop it right behind that fan. So now we're only going to cool, and we're using a fancy, a more expensive variable speed cooler. And we can run that and see if it makes any difference. Yes. Everyone's here now. So you can just let that run, and we can, but we're ready for the awards now. You can just let it run, and if you need any help, we can walk around and help you as we go. Thank you very much for your attention.